Now, whether anybody has got this one. Anybody? This is the answer. You got it? So now, let us proceed further. That the second differential equation is correct, that's what we have said. That is the dLOT upon dt plus LOT is equal to LAT. That is correct because the scenario in which we have developed the basic equation remains the same. Right. That is correct. Now the question is we have to derive the expression between L in T and LAT. So we consider the same scenario that the differential equation needs to be redeveloped. The differential equation needs to be redeveloped. The diagram I draw here. And I choose one more thing, that signals and systems has nothing to do with any specific branch. So voltage, current mean electrical side, water levels here, other kind of pressure and those things mechanical. So it is an interdisciplinary subject, and water level model I have chosen because it can be understood. The electric parameters are not so easy. So we now have this system. Now, this is L in this LAP. So now, between LA and all things are done. Now remember that a system with an input feed, a valve and a tank with outlet is a different system. So this will have a different differential equation. So that we redevelop. The first thing is very clear. That is for the valve, what is FT? This FT I am talking about. And this I will give as other number. Ft is equal to what? L in T minus LAT, right? Upon, there is no change. For the ball, L in T, LAT, whatever it may be, no change. Now, the question is about what is WOT? WOT was the quantity, now not O, now what we should say? A, right? Because it is middle time. So WAT, what is WAT? If this was not there, then WAT if this was closed, this was not there, WAT was merely because of flow T. So dWAT by dt is equal to Ft, right? Is it clear? The relation between volume and flow is of differential nature. So what is dWAT by dt is the net flow. That time I have not used the word net flow because there was only one flow. Now in this case, by common common sense, what would be dWAT by dt? dWAT by dt is equal to, will it be equal to Ft? No. It will be equal to Ft minus. Why minus? Because it is going out, right? Minus this, we can say F1T. I should use some, I kept this as fixed and F1T. Right? Is it okay? Minus F1. Is it right? Is it okay? So what is Ft? What is F1T we will discuss. But what is Ft now? Ft is dWAT by dt plus F1T. Right? So Ft is equal to dWAT by dt plus F1T. What is WA? As regards to what is the relation between WA and LA? That is fixed, there is no change. WA is equal to A into LA. WAT is equal to A into LAT. So this I can write as dWAT by dt is equal to A dLAT by AdLAT. Is right? Is okay? I think no new rocket science, no new theme. Is it right? It's very simple. It's plain now. It is. The only difference is that some part of differential calculus is there, except that it is high school level scholarship problem. Is it right? Except the differential equation part, it is very simple. Now, these two, that is 1 and 2, if we bring together, what we can get? A second, that is A dLOT by dt plus F1T. I have kept F1T as it is right now. Is equal to what? L in T minus L AT upon O. Is it right? Yes. O, or to be very precise, we should use A1 and O1, right? Because it's for the first.
L1, A1D, L1T by
DLA, sorry, right? Is it okay? DLA, D, not LO, LAT by D, that is this equation. A dLAT by dt plus FT, F1T is this, and this L in T minus LAT upon O, 1 I should use and A1 I should, right? And what is this equation? This is as it is current equation. dLO1 dLOT by dt plus LOT is equal to LAT, right? So this. Now we multiply by O1 on the other side. So O1 A1 plus O1 FT, F1T, and this is equal to 1, right? So dLAT by dt plus O1 F1T is equal to L in T minus LAT. And what was the earlier equation? dLOT by dt dLOT by dt plus LOT is equal to L A. plus LOT is equal to, is it right? LAT. So now, in previous case what we did, this we bring on the other side, right? So we said that plus LAT, and we take minus O1 F1T, which was missing, right? So our mistake was this part was missing, right? And when this part was missing, then straight away what we did? Simply we differentiate this term contains DLAT, so we differentiated this and put it here. That is DLAT by dt. So what we get if we differentiate, there is no change here. That is say d2 square or d2LOT upon dt square plus dLOT upon dt is equal to dLAT upon dt. So this unwanted term we put here. This also we did not want, so we put here. So d2 LOT upon dt square plus this equal to LAT. So that also we then put here. So what we get ultimately? We get here as
in the first equation, O1 into A1 will also come. No?
Yes,
First
sir.
equation.
so
O1 into A1 into dLAT by dt will come.
this no.
O1 into A1.
We consider it as 1.
We, to make the thing simpler, we have presumed that O1 A1 and O2 A2 are constants as well as before.
Multiplication.
O1 into A1 is constant, and for means in the this is a complex number 2 tanks. In the single tank system, OA was there, and that OA we have assumed the arrangement of the area and the opening such that their product is constant, and that is 1. Not constant, the product is constant, but that is 1. So the things are simpler. So what we get? This equation we have. This equation we have got. This we have got. That we put here. So what we get? d2 LOT upon dt square plus same thing. This is first term d2 LOT upon dt square plus dLOT plus dLOT upon plus dLOT upon dt plus dLOT upon dt plus LOT. So I write once again dLOT by dt plus dLOT by dt plus LOT, but now that is no longer only LAT minus O1 F1. That is equal to LNT minus O1 F1. So what we get? d2 LOT upon dt square plus 2 dLOT upon dt plus LOT is equal to L in T plus O1 F1T plus O1 F1T. Sorry, minus O1 F1. Minus O1 F1. What is F1T? F1T is the
Second.
flow outlet, that is flow. So here your smartness matters. How can you effectively do that? And what is F1T?
It will be area A into D LOT by dt. F1T.
F1T equal to
A into D.
which A? You should not say A now.
A1.
A1, not
A2.
A2. A2, right? So what? See, we should not be lazy in moving because that is important. This diagram F1T. So this F1T is outlet for the middle tank, is input to the second tank. So the input to the second tank is dWOT upon dt is F1T, right? What is F1T? dWOT upon dt. This is output tank. So WO. So dWOT upon dt is equal to F1. What is WO? A2 dLOT upon dt is equal to F1. Right? And now we use this. So that is equal to ln T minus O1 A2 dLOT by dt. And that is brought here, right? That is brought on the left hand side. So when you bring it on the left hand side, d2 LOT upon dt square plus 2 plus O1 A2 right? And if we have presumed OA to be equal to 1, so both systems, if O and A are, OA is O1 A1 and O2 equal to 1, O2 A2 equal to 1, that doesn't remove this constant. If O1 equal to O2 equal to A1 equal to A2, all are 1. O1 A1 1 is not enough now. If all are 1, then this becomes 1, otherwise this is another constant. Means mere O1 A1 equal to 1 and O2 A2 equal to 1 does not make this to be 1. This is a different constant. So it will be another constant. So as he has developed the entire thing, remember that what mistake we normally do is we develop the equation for second wall tank. We develop the equation for first wall tank. We have already developed the equation for a single wall tank system. The single wall tank system equation is exactly there for second wall tank, no problem. But for the first wall tank system in this two tank model is not at all, situation is same as one tank model. So the first wall tank model of the two tank system results is a different system, and that requires a different differential equation to be developed, right? So this, and if that is O1 A2 is also 1, then what I had said, that the constant is so d2 LOT by dt square plus 3d LOT by dt plus LOT is equal to ln t. Is it clear? So I hope that any system in the world given to you where something is directly proportional to the means level and flow. Level is a variable and flow is a variable. Level and wall is the component. For a wall, level, difference and flow are linearly proportional in direct manner or are directly proportional. All the linear systems, directly proportional. Whereas for a tank, level and flow, there is a differential proportionality. And when wall and tank come together in the system, one differential proportionality and one direct proportionality needs to be coupled up with each other, and that gives rise to a differential equation. So you should be able to develop differential equations for all things in the world. So what we can have first, then the first tank can be normal cone, the second tank can be inverted cone. So all permutations and combinations, spherical, inverse spherical means tutorial I will give that. First is conical, second inverted cone. First is spherical, second is inverted spherical. First spherical, all possible combinations. So normal, that is constant area, then spherical, reverse spherical, conical, reverse conical. And there, now what can we go for? Something which is random. Any kind of odd shape, if you bring, what will happen? Any kind of odd shape means a tank, you can construct a tank, right? So the tank can have a way, means this is constant cross section area. This is inverted cone. Cross section not constant, but the cross section area changing in some regular manner, defined manner. Where if you bring a tank like this, it will change. And further, there is an elastic tank. Means you have got a expandable plastic sheet, and as water comes, the sheet expands, so the capacity expands. So in that case it will be a very complex situation where the capacity depends on the, means it is what we can say dynamic, not all the static, but that is dynamic. That is, it depends upon how much water is put there. The cross section area expands. So it is a very complex system. Means, see, we say that for a capacitor, current is what is Q equal to CV. We differentiate. So current is dQ by dt is equal to, we say C dV by dt. But why? It can be C dV by dt plus V dC by dt. Because we presume that the capacitance is constant, but that also may change. And in that situation, the thing will be different. Also, the tank capacity. Suppose that the tank is of somewhat plastic tank. It is not on its own expandable, but you can squeeze it. You can expand it. Right? So the tank, that is the equation, it means we said that WO T for a constant area time, we said that is A into LOT. But this A was constant. In other cases of formula, but this can be a function of time. You can, are you getting me? A tank is there. You can have mechanical assembly by which all, if it's a what cubical tank, you can squeeze it. Are you getting me? A cubical tank is there and 3 ends fixed, 1 end variable. Is it laksha laga? A cubical tank with other, we presume that leakage and all these things are not there. The other thing, the one face of the 4 faces moves like this, maybe in a sinusoidal manner. So this A is some function of time. Maybe A is 1 plus cos t. So it moves like this. So what that system would be. So these are various ways in which the systems can be developed, the differential equations can be developed. Now we take a break, and so You are very much anxious about the break because you want to solve the remaining differential equations, right? And now it's around 12:10. We just prepone the meeting time or postpone. We postpone the post lunch time at 1:45 to 3:50.